Hi everyone. First, we would like to thank you for your interest in Automation Studio, the all-in-one, user-friendly circuit creation, simulation, and troubleshooting software for hydraulic, pneumatic, electrical, and PLC. In today's webinar, we will go over the pneumatic and electro-pneumatic portion of Automation Studio. We will go over basic manipulation. We'll create a pneumatic circuit. We'll change properties on some of the components of the circuit. We'll insert measuring instrument. We'll create an electro-pneumatic circuit. We'll insert a bill of material on the schematic. We'll customize the library so it fits your current hardware equipment, and also how you can limit the use of only a specific number of components for students to create their assignment. We will also insert pictures beside the component. We'll show how to record video in MP4 format that can be shared to your students or on YouTube, for example. And we'll go over the manufacturer's catalog. So now we're going to go into the Automation Studio. So this is the actual Automation Studio interface. So when you're going to be launching Automation Studio for the first time, this is your 8.5 by 11 sheet. Okay, that's on your screen. So you're always aware of the place that you take on that sheet. And if you want to change the size of this sheet, how you can do that is you right-click on the white area of your screen, and you're going to go to Document Properties. And from here, the page setup, you see here you can select different page, 8.5 by 11, 814, 17, and this is where you're going to be able to change the page layout and also other page properties. Okay, if you want to change something, you click on this icon, open and modify, and this will open the entire sections where you can change all the, for example, if you want to work on metric or imperial unit, okay, these are the places where you can change that here. If you go project here and you go standards, then you'll be able to choose here if you want imperial or metric. Okay, I had the question yesterday asked to me. It says I want to have PSI and GPM by default, and it was showing a GAP. Okay, so by going metric or imperial, you can do that. And once you've changed it and you click here, it's going to ask you to save, and now this document will be the way you want it to be. Okay. So once you've done that, if you want, obviously, next time you're going to open the circuit, you want to always use this sheet. You can actually go here, project, and save this project as a template. Okay, so for example, if you've put like a logo of your school, you've put a title block, a map locator, and you want the students to always open this when they work, and they always going to have the school logo at the bottom, you put that there, and then you save it as a template. And next time you're going to do a new project here, it's going to propose to you the template that you just saved. And keep in mind that when you're launching Automation Studio, it will always reopen the last template you've used. Okay, so if you open the template you saved with your school logo, for example, next time you launch Automation Studio, it will automatically load this template. Okay, so this is something I didn't go over yesterday. That's why I wanted to make sure we go over right now. And now let's start working with the software. So here is the library of components, okay, that you have in Automation Studio. So today we'll focus on pneumatic. Okay, so I'm going to build a basic pneumatic circuit. So as you can probably have done already, is you can simply go in the main library here, select the component of your choice, and simply drag it on the sheet. Okay, so I have a double acting cylinder. I'm going to come down here and I'm going to take now a 5-2 directional valve. You see my valve has a mechanically button here and a solenoid. Okay, so if that question mark here, it's because on the solenoid part, it needs to be connected to an electrical diagram, which I don't have at this time. Okay, that's why there's a question mark there. Now I can connect these elements together. Okay, those red dots means that there's no connection. And how to make the connection is, you see when I position my cursor close to this, it will change as a target sign. So I can click once on the button, let go of the button, and click again on the other one. Click here, click here. Some people sometimes keep their finger on the button, okay? It still doesn't work if you just do a simple connection like that. But imagine if I want to make a connection that goes around the cylinder, for example. I click here, click, 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 and click. Okay, so if you keep your finger on it, you cannot do everything we just did, okay? So that's why it's good to let go of the button once you make a line, okay? So now let's also go and put my pressure source. Pressure source over here. I'm going to put an exhaust. It's a Windows-based software, so I can simply right-click here to copy, and I can paste. I could have done simply select it, Control-C, Control-V, or I could have simply hit the Control key while I move it, and you see there's a little plus showing on my cursor, meaning I'm copying the component. Once I let go, it copies. Okay? So make the link here, copy here, click here, click, 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 and click. So now that I have created this circuit, I can directly go into the simulation mode and actually push on that button here to test my circuit. Every time I let go of the button, it brings back the valve because of the spring on the other side. Okay? So you may feel like it's moving a bit too quick, and you want to slow it down a bit for the students to have more time to see what's going on. Okay? Obviously, if you go in simulation, we have different simulation mode. Slow motion, step by step. If I go slow motion, I don't like it much because it goes like big, like, it moves like still like very square, okay? Square movement. So what I prefer to do on my own is that I like to click on the pressure source and actually reduce the orifice of that pressure source so there's less air going into the system. So 0.02 inch. And now if I simulate again, you see it's much slower now and it's not as square as it used to be. Okay, so this is a good way if you want to slow down. You can just reduce the size of, let's say, the pressure source, or I could have actually brought here a throttle valve like this. And I want to put it here on the outlet as a meter out for my cylinder, okay? There's something important that you need to know, okay? Right now, I put that component on my sheet. And if I bring it now on that line, you see the red dots are there. That means it's not connected. And if I simulate, you see the line is going through the component. This never happens in Automation Studio. You never have any line going through components. So if you see this, it's because it's not well connected. Okay? So I can move it away. There's one way to actually connect the component that has already been placed on your schematic. Is you hold the shift key down as you bring it back here, and it will connect automatically onto the circuit. You see now the green, the lines, the circles are black. And if I simulate, it does not go through the component anymore. But now it's like a meter in because the check valve. So I'm just going to disconnect. So hold the shift key, move it away. I'm going to right click on it and do a transformation and horizontal flip. So now you see my check valve is on the right side. So I can just go again, hold the shift and bring it back in the line like that. And now if I simulate and it extend, let me just lock it in place. I'll show you after. You see right now if I push here and I let go, it retracts, okay? But if I want to lock this valve in place, I can directly click on the spool like that and it forces it. And if I come here and I close it, you see it stops. It's compressing the air, and then if I go like this, it's going to go faster or slower. So you can adjust the speed using those also if you want. It's really up to you to decide. So if I put it very small, it slows down. And if I put even smaller than that, okay, so obviously the air is compressible, so it shows in the software, so it's Got to compress at one point. You see the pressure now, it's red because it's compressing, and you see how slower it's going now because it needs to go through this component which is almost close. Okay? So let's delete that and just keep it the way it was for the moment. Something also important to know is that if you take a component straight from the library and you drag it on the line right away, it's going to automatically connect without having to hold the shift key because you took it straight from the library. Okay? Those are simple manipulation tool. And also, you see me, I'm just like working around and moving my sheet all the time. The way to move your sheet, obviously, if you go to the view here, you can click on panning. And if you click here, you're going to have an and, which you can click and move your schematic. And then if you right click, you're going to lose that feature. Okay? But I prefer to only hit the space bar and click and move. That's much quicker. You make some drawing, you want to move it a bit, you move it back. So space bar is really quick. And also, you see me like zoom in and zoom out sometime. I can go here, some plus, some minus, window, page, all components. Or I can hit the control key of my keyboard and roll the wheel of my mouse. This will zoom where you're pointing your cursor. Okay, so wherever you point your cursor, you're going to zoom at that location. So now we've created this circuit. Every component in Automation Studio, if you right-click on it, there's a context help that allows you to go and see and read a bit about this component. You can cut and paste the information as well if you want. And everything you draw, you can select, you can copy, and you can go in Word, for example. Oops, sorry, that's not Word. You can go in Word, and then you can paste directly into Word. And as you can see, the quality is great. It's all vector graphics. So when it prints out, it looks really professional. Okay? So for you to prepare assignment or for students to do report, they can cut and paste their work into Word, PowerPoint, any Microsoft application. Okay? So that said, what we're going to do now is I'm actually going to put a, let's say I'm going to put a push button here instead of that. I don't want the students to see this. I want them to just see one push button, as simple as that. And I don't have this component in my library here, okay? Obviously, I can expand the pneumatic section here and go into the directional valve, go into the 5-2 valve, and try to find the one that I'm looking for, okay? But it could be complicated and it's not sure you're going to find the model that you want there. So what you can simply do is you can double-click on this directional valve. And once you're in there, you're going to go to the builder. And here you can create any type of directional valve that you want, okay? So here, for example, I'm going to click on this. I'm going to delete it. Click on the solenoid and delete it also. I'm going to click twice on that question mark. And I'm going to be able to choose a different command here. So I'm just going to go for the push button. And I'm going to put it in the middle, like this. I could have done the same thing with the spool. If you click twice on the spool, you can actually change different configuration for your spool. Okay? So depending on the number of ports that you choose, you're going to have different spool to choose from. So once I've changed my valve, I can just approve. And when I go out here, you see now I have a push button. I could have put the spring in the middle too. I didn't, but if I simulate again, I push here, and there you go. And that looks more maybe like the one that you want the students to see. Okay. Now that I've done this, what we're going to do is, let's say I want, instead of putting a spring here, I'm going to put a pneumatic pilot. And I want a roller valve to actually make the cylinder retract. So I'm going to click twice on this valve and click twice on the spring. And I'm going to put here a pneumatic pilot. I approve, and when I close, there's my pilot. So now if I simulate again, there's no spring. So if I push once, it will remain in that position because there's nothing to bring it back. So I can stop simulation, and now I'm going to put a roller valve here. So I know I have one done in the main library, which is here. I need to flip it 90 degrees. So I'm going to right click, transformation, rotate 90 degrees like that. Okay. These are the mechanical contacts. These diamond shapes is which needs to be one on top of the other to be activated. So if you put it a bit upper like that, it will not trigger this because it doesn't go over it. It's important that you put it exactly in its path. But now I want to put this at the end of the stroke of my cylinder. But I'm not too sure where it's at. So what I can do, I can simply double click on that cylinder and I go to data. In the data tab, this is where you can change all the properties of your component. So the piston diameter, rod diameter, stroke length, weight on it, everything you want can be changed here, okay? Right now, you see all the fields that I see have a star, yellow star like that. These are because they are the favorite fields. That star, if I uncheck it, it will display all the other fields. Damping coefficient, internal leaks. There's a couple of more information here that you can enter. If you want to go put part numbers, component name, part number, even price, you can document your component as you wish here. Okay, and if you want to identify some for you that's going to be favorite next time, you just check that star. Okay, because sometimes people contact us and they say, oh, I cannot modify this. Well, how do I do it? And a lot of time we just say, okay, I'll just uncheck that star and you'll see the other field that you're looking for. Okay, so keep in mind that this could be an issue. So I'm going to go into the extension of my cylinder and I'm going to put it to 100%. You see now it's fully extend. So I'm going to position those two diamonds shape one over the other like that. So I know that this will be tripped when the cylinder reaches the end. And I'm going to click back on the cylinder and put it back to 0%. Like this. Now I need this to trigger this valve. So I'm going to just make a bit more room, okay? So I'm going to take this valve, I'm going to select all this and move it down a bit like this, okay? Then I'm going to take this, so click, click, and click, because I want this to be piloted when this gets triggered. So I'm going to right click on this line because this is now a line function. It's a pilot line. So now it's going to display a different look for the line. So you can tell your students, I want you to identify the pilot lines, pressure lines, and things like that. It's for them to do it. And now I need to actually pressurize this valve because I want the pneumatic signal to go push that back. So I'm just going to come here, take a pressure source, right click, transformation, rotate 90 degrees like this. So my pressure source is going to be here because I don't want no pressure to go by unless it's pushed. And I'm going to put an exhaust, right click, transformation, right, and like this. Keep in mind that every port that is left open, once you launch the simulation, these ports will be blocked. It's not like on a pneumatic system, if you don't put like an exhaust on a valve, the air is going to go out. In Automation Studio, we need to put an exhaust. Okay, so this is a primary feature. So now if I launch the simulation again, I'm going to push here, cylinder extract, hit the valve, and then goes back. So I've just made a sequence now using a roller valve at the end of the cylinder. Okay, so what we're going to do now, the next step, is that I'm going to create the same circuit, but this time I want to have two valves that will control the cylinder going back and forth all the time. Okay, so I'm just going to move this a bit to the right. And instead of using this to trigger the valve, I'm going to use a proximity sensor attached to a cam, okay? So I'm going to come here, pneumatic. First of all, I can go pneumatic like that. I can go into sensors. I can go proximity sensor, various, so there's a bunch of different sensors that you can find. So I can take this one. I drop it. You see, again, I drop it the two diamond shape over each other. I'll call this, let's say, A0. And I'm going to take another one here. And I'm going to put here A1. I could have also extend 100% to know exactly where it goes, but by experience, I know it goes there, okay? So now, because if I put two valves like this up here, it's going to be too crowded. You know, it's not going to be easy to understand what's going on, okay? So I'm going to need, first of all, I'm going to group those three elements together. You see, if I select them all with the valve, right-click, group. Now they move as a whole, okay? So I'm going to actually flip this 90 degree because I want it to be more directly in line with this. So I'm going to right-click, transformation, vertical flip. And then I move it like that, and you see my line is going to come down. So this is going to trigger the valve on this side, but I need to have another one on the other side to be triggered by another roller valve like that. So I'm going to click twice here. Go again onto the builder, double click on the push button, and instead choose a pneumatic external pilot like that. I can place it again where I want. It doesn't matter for the simulation at all. Okay, and then once it's placed in this location, I can approve. And now you see I've moved it a bit in the configurator, so it disconnects. I just need to move down a bit to be connected, okay? So now I'm going to, like we did before, I'm going to hold the control key down and copy this entirely with the two pressure and exhaust. So if you don't want the students to waste time doing that, I'm going to show you right after that how to create a custom library where you can store this already grouped like that, okay? So let's flip it again the other way. Flip vertical. And I'm going to connect this here. And I'm going to click on the line because this is, again, a pilot line. You don't need to do it, by the way. You can leave pressure lines everywhere. You know, it's just because I wanted to see it like that, okay? Now, I'm going to bring this down a bit because it's way too hot for nothing. And now I'm going to go into my sensors again, and I'm going to take the mechanical contact like this. This one is a bit tricky, okay? There is no diamond shape, okay? But you need to place it like that because once it gets triggered, this will push and the roller kind of follows this, okay? So this has a question mark. So I need to trigger this to one of my sensor. So when it retracts, I want it to go out. So I'm going to link this to A0. Click twice on it. I'm going to go into the variable assignment window. And this is where you can use here the filter because this is called A0. So I can filter for A and even 0 if I want. And you see it's here. If I click twice on it, you'll see the question mark on the left will change to A0, confirming that the connection is made, and they're hyperlinked together now. I'm going to take another one here, and I'm going to link this one to A1. So A1, and A1 is here. Click twice, and there you go. So now if I simulate this again, it's just going to go back and forth like that because I have nothing to cut the air, okay? So it's just going to go and go and go unless I put something to actually cut the air to this entry here. So if I want, I'm going to make it complex, okay? I mean, don't judge my my drawing skill here, but I just want to make it, I want you to see what you can do. So I'm going to take another, let's say a 3-2 valve this time. Okay. I know I can just use one push button like that, but I'm just going to show you, let's do this. Let's just use this for simple, okay? I'm going to put the pressure source here. Go like this. And again, I need to put an exhaust here to stop it. So if I start simulation, if I push air, it's going to go. And if I let go of the button, I'm going to cut the air. So it's going to stop right in this place. Because I'm cutting the air supply. I'm not letting it finish a cycle. I'm actually cutting the air. Okay. So this is the type of thing that you can do. You can do those setups like that. And it's very easily, as you can see, to manipulate the tool and create the circuit that you want. I could have put here another 3-2 with two pilots again and put two push buttons on each side to do the same job, okay? But this is just like a way of doing it. I could have also used, I don't know what you call this in English, but the push button with detent, yeah, a detent. So I could have come here and clicked twice here and use a detent like that and remove the spring to lock it in place, okay? I could have done that. Something I did not tell you guys yet is that, you know, when I simulate, if I want to, now I have to push this and I have to keep my finger on the button because I have to maintain the push button. If I let go, it retracts, okay? But if you click directly on the spool position, you will lock that spool position in place, okay? And the only way to remove that forcing is clicking on one of the two commands. If I click on the spring or here, it's going to take it off. You see if the hook is here, if I click on the spring, it goes away. This is important because if, for example, you have a solenoid valve that is controlled with an electrical circuit, okay? If you have a checkbox here like that, and you have a solenoid here, and you trigger that solenoid, even though it's well connected, it will not move because it's forced in that position, okay? So keep that in mind because I've received many requests, you know, down the road. There was before we used to have a very small triangles, people weren't seeing it. Now with the big check, you see it, you know. But sometimes they send me a circuit, say, well, how come it doesn't work well? It's simply because some of the valve on the circuit have been locked in place, okay? So keep that in mind. So what I'm going to show you now, before we go to the Electro-Pneumatic, I want to show you the Customizable Library, okay? Again, I like this feature a lot. It's a great feature. I think it's going to help you guys and your students a lot. I would strongly recommend that you use it, but it's for you to decide, okay? But let me show you how it works. It's very simple. The library here, it's pretty big. Okay, you see how I went before into the sensors, and I had to know it was in others to find it, you know, so it's not obvious that you will look there. So you can create your own library. If I click on this book here, new library, the software is going to ask me to save it somewhere, okay? So I'm going to choose to save it, let's say, on my desktop, training, pneumatic, and let's just save it there and call it, let's say, webinar. You can put your school name, you can put your name, it's up to you, okay? So this is you see, it's a different tab in my library, and this is a file. That file, you can share it with your students. It's like a Word document. You send it by email, and then they're going to download it on their machine, and they're just going to go here instead on the second icon, open a library, and they're going to go look for it, okay? So it's really like having a file, okay? So now I have a library called webinar, which is empty. So I'm going to click a section here. In this case, let's call it pneumatic. Oops, sorry. Let me just rename that. Pneumatic. Then I'm going to create a subsection to that while it's highlighted, and I'm going to call this lab 1. So again, I'm going to just simply take this component and drag it on this part here to save it in my library. So you see that valve is a valve that I'm going to use with my students. I drag it here. It is saved the way I want. That push button, that 3-2, I put it there too. I want my students to actually have a valve like this with the pressure and exhaust. Drag it as a group. They all will all be there, and you can rename it the way you want. 3-2, whatever you want. I could have even group it with the cam on it. I can select this, group it, and put this here with the cam. So this is so much easier. You know what, when the students make the first couple of labs, You want them to put pressure source, exhaust, just so they're aware of it. But as they go further in the classroom, in the class, maybe when they reach lab 3 or 4, they will find those elements already put on the components because they need to focus on other part of the circuit. Okay, so this is really helpful. So for example, if you have a trainer, an hardware trainer, let's say it's called, you have a pneumatic Parker trainer, for example. It could be LabVolt, Amatrol, Festo. We don't care. Our software is it's very flexible, so you can adapt it to any equipment that you have. Okay. So let's say I have a Parker pneumatic trainer. I'm going to click on pneumatic here, do a plus, and I'm going to call it, let's say, Parker trainer. And if on my trainer I have components like this, I can click twice, go into the data again, put the properties of that component as close as possible to what I have on my trainer, and give it the exact same name that I have on my trainer. Let's say it's called Parker PA-A for cylinder, let's say, okay? I can display the name on my drawing. If you check the box here, you see the tooltip valuable is displayed on the editor. So if I close, you see the name is here. I can place it wherever I want. Once it's placed, if I move the component, it will remain at that location. Okay, and then you can click on it here. You can go to the Edit tab, and you can actually change the size of the text. You can make it bold. You can make it green. It's really up to you. Okay, then I can just connect it back. And then I can drag it in the Parker here, and it's going to have the exact same name as they are listed on your trainer. And let me open one library that I did to show you something. So you see, I just click on the open icon. I'm going to go browse for the library. Let's say you're Christian. And in this library, what you can also do is you can put pictures beside symbols. Okay, these pictures are more for hydraulic components, but you get the idea. Okay, it's the same thing. Okay, you can put the pictures like that beside the symbol. So when the students work from home, he may not have access to the equipment, but he's always aware how it looks like because there's a picture. And this picture can be a picture of your own equipment. That's cool. You put it beside it like that, you group it with the component, and you store it back in your library. I'll show you how simple it is. Let's take a cylinder, for example. Okay, let's take my cylinder here. I'm going to copy down here. Okay, let's say I want to put a picture above this. I'm going to go to Home, Picture. You see my cursor change. I can actually drag a little square somewhere, and it's going to ask me where's the picture. I know it's on my desktop, so I'm going to go here and actually take a cylinder picture. Then I can shrink it. That's the way I like it. I can select both components. I group them. I go into my webinar library, Parker Trainer, and I drag it in here as being a component from Parker. You see, I went to a school back in February when I could travel, and a teacher came up to me and he brought me this component like that. This is a component from a manufacturer out there that people that know this will automatically know what it is. But I would actually, so he came and he brought me this part and he says, what can you do with this? So we went on Google. I looked up for the picture. I found it, cut and paste into Automation Studio directly. Then you see here, this is what the manufacturer actually draw on his plate for the component. So I redid this exact same drawing in Automation Studio like this. So now if you go in simulation mode, everything works. Okay, it's exactly like it is working on this equipment. So when you drag it in your library, you're going to have exact part number as it is listed on the equipment that the students need to use. This library, that customizable library, I'm telling you, it's not long as you can see, and it's going to simplify the life of your students so much, okay? Because they won't waste time looking in the library for what they want. Maybe in the lab 10 or 11, you want them to be a bit more confused and you want them to go through the main library, no problem. But at the beginning, this is, I think, the way to go to make it easy to use quickly. Okay? So this is done for the custom library. Now, I want to create that same logic, but this time using a electrical control library. So I'm just going to get rid of all this. I'm going to get rid of this, delete this and this, and I'm going to put my pressure source here and delete that. So for this lab, I'm actually going to need to have 2 solenoids on each side of this directional valve. So I'm going to click twice on it, go into the builder, click twice on this pilot, and actually choose my solenoid. Go on the other end, click twice, and choose a solenoid. I approve and I close. And now I have my 2 solenoid, where you see the question marks here because it needs to be connected to an electrical circuit. Keep in mind again, if you don't want the students to do this, you put your valve in your library, and then you're going to have a library with all the valves that you use. Okay? So they won't have to do it. It's up to you to decide. Now, right beside this circuit, I'm going to come here and drag and drop from the electrical control library a little relay sequence to control this circuit. In this library here, electrical control, we do not simulate voltage and current. This is mainly for control sequence. Okay, you will see tomorrow I'm going to do the electrical training, and I will show you that if you want to use the element from the electrotechnical library here, you need to use a different diagram. Okay, this is just for logic control. It's like a ladder diagram. Okay, so let's continue here and make a sequence. So let's put like a 0 volt here. I'm going to put a push button over here. I'm going to name this start. For the one that were there yesterday, it's going to be a bit different. Don't worry, it's not going to be exactly the same. I'm going to put a relay here, and I'm going to call, let's say, CR1. And then I'm going to connect this together. And I want to have a latching contact on the start to keep that signal energized. Okay? So I'm going to drag and drop from the library a normally open contact. And as soon as I drop it on my schematic, the software is going to ask me to which relay do I belong. I want it to link with CR1. So I'm going to filter for C, and here's CR1. Click twice, and now they have the same name. So this is going to latch my CR1 contact. Okay. Then I want to trigger my valve when I trip that. So, okay, so I'm going to take the control one here, CR1. I can hold the control key, like I said before. If you do a copy of a component on your schematic, you will copy all its attributes, all its properties. So if I hold the control key and I drag it down, you see it's already linked to CR1. And now this one, I'm going to energize a solenoid. So let's come here. And I'm going to call this, let's say, A+. I could have put PAA+, just, so, but anyway, A+ is the, and then I can connect this like that. You see components stay connected, so it's easy to just realign it the way you want, so it looks a bit better aligned with the other one. So if I simulate now, my A+ is energized, but nothing is moving because I forgot to assign the A+ to the solenoid. So all I need to do is click twice on this directional valve. Select the solenoid on the left, and this one, link it to A+. Here's A+. Click twice, and now it's connected to A+. But I automatically know that this is not spring return, so I'm going to have to, when it reach A1, to energize it the other way around. Okay, so now I'm going to need to use a proximity switch here. And I'm going to say that when I reach A1, so I'm going to need to link it to A1. So click twice on it. My filter is already set to A, and here's A1. Click twice. So I'm going to connect this here. And when I reach A1, I'm going to energize another solenoid, but this one is going to be A minus. So when I simulate, up again, sorry, I need to add to put this A minus, click twice, click on the other solenoid. It's already filtered to A, so A minus is here, click twice, and now the link is made. So if I simulate, push, it does not work because I'm still also energizing A plus. So you see, this is why Automation Studio is good, because your students will actually troubleshoot their own schematic as they're working with it. I'm just going to move this a bit because my cylinder is extending in my electrical circuit. So this is why it makes them understand better, because they're going to fix the issue, then they're going to understand what they've done wrong. Okay? So let's say that I want that in order to cut the signal of A plus, I'm going to need to put maybe let's say I'm going to need to have A0 here in series. So it's going to be this and 0.1 to go out. So I'm going to take a normally open, again, switch here. I'm going to drop it directly on the line. As you remember, it connects automatically. And I'm going to click twice here and link this to A0. So now I have a condition. So this needs to be on and this to go out. So if I simulate again, okay, go out, go back. So now it's working fine. But I can't stop it. So I'm going to need to put a stop somewhere. So there's two ways I can do it. I can just drag and drop a normally closed push button directly here on the line and call it, let's say, stop. So if I simulate, start, it's going to go. Okay, it's going to go like this. And then at one point, if I hit stop, it's going to finish a cycle because I'm not cutting the air, I'm cutting the sequence. And it just stops there. So start, stop, it's going to finish the cycle and stop. So this is how we can very easily create circuit like that in Automation Studio, validate, create the control part. This is the North American standard for the logic like that, relay logic. Some of you may use other software that are using the European standard. Keep in mind that we have both here. Okay, so when I say that Automation Studio adapts really well to your curriculum, whether you're using equipment that comes from Germany, the Europe, or whatever, you're going to have exercises that are using the IEC standard, which we have here. And if you have any equipment that's made in the States or anywhere else, you're going to use North American standard like that. So we have both, okay? So you can show students the difference between one and the other, okay? So now I've showed you pretty much what I wanted to show for this. I did not show you, I forgot about the measuring instrument. Obviously, if you go to pneumatic here, you go measuring instrument. We have pressure gauges, pressure indicator, you know, so you can use those on your schematic. You can also, for example, if I put like a pressure indicator, okay, I can rotate that. So rotate 90 degree. If I connect it here, you see it's red because I did not hold the shift key. So I'm going to hold the shift key now and drag it, and you see it connected. So if I click twice on it, I see that it's going to go the pressure, display pressure, and its maximum pressure. So as soon as I simulate, when there's pressure, the light goes on. Okay, so this is done. Changing paper size, we did it. Changing units, you see now it shows PSI. If you click twice on the component, you can also change here the unit you want to display. Okay, something interesting with Automation Studio is that, for example, if you click on the cylinder twice, right now, as you see, the measurements are, let's say, 9.8 inch, blah, 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 okay, because it was done in centimeters, 25 centimeters, okay? But when you change units, it does the conversion for you. So if, for example, you have a nice exercise that you found online, and it uses all metric measurement, but you want to use the imperial unit. So instead of trying to do the conversion somewhere else, you just plug in the value, let's say 30 centimeters, and when you go to inches, it's going to give you that measurement in inches, 11.8. Okay, so it really adapts also the value to the right unit that you're picking here. Okay, so this is something that you can use. And again, like I showed you at the beginning, if you want your document to display all the time metric or imperial unit, you just change that in the standard, and then you save your document as a template. Okay, let's say, for example, let's say I'm going to do a template very quickly. Okay, I can insert a bill of material on my schematic. Let me erase this part. I think you understand what we did today here. Let me put a BOM. Okay, just do a little square, and this will generate automatically a list of all the components that I have on my schematic. Okay. So you see, here's the list. I can unlock this to actually shrink it. Okay, I can add columns. I can decide which column I want to display. Okay, I can do whatever I want here. I can reduce the size. So every time you drag a component out from the library, let's say if I go logic unit, an N, an or let's say a flow valve, let's say a non-return valve, let's say like this. I drag it out, boom, you see automatically loaded in the bill of material, and if I erase it, it goes away, okay? But let's say I want this, and I want to erase everything I did. So it's just lying there like that on my page. But I want my students to always use this page because I want them to have the list of all the components that they're using built up here. So I want this to be a template. So my document is done. I'm going to come on this icon here. I'm going to do project, not just save the project as an exercise or something, but as a template. I'm going to click here. Then I'm going to name it, let's say, webinar pneumatic, let's say. Okay, I could have named it anything I want. You see the names here? Some make sense, some doesn't. It's up to you to decide what name you want, okay? Then I do save. So it's going to save my template, okay? And now what I can do is if I click on the first icon here, new project, because you remember what I said to you before, when Automation Studio launch, it will reopen the exact same project it had opened the last time, okay? So I'm going to need to go here, new project. I'm going to choose the webinar. So it's going to open this project that I used, okay? And you see, as soon as I start drawing, without doing anything, it's going to build up with the list of all the components that I'm using. And now if I close Automation Studio, and I relaunch it, if I would have created a logo of my school, you know, anything like that, so when the students are printing it out, it looks professional, I could have done that. And now you'll see when this is going to load, it's going to load the page that I just had with my bill of material on it. And if I send this PRG file to the students, they just save it in their template folder, and they're also going to have access to this. So you see it's going to load up, and it's going to have my bill of material already on the page. So you see, and if I start drawing, whether it's hydraulic or pneumatic, you know, it's still going to list the components there directly. And I could have had another column saying manufacturer, another column displaying the price, whatever you want, okay? So this is pretty much what I wanted to show today in my webinar about the pneumatic creation. What I'm going to do now for the last couple of minutes, I'm just going to open a couple of circuits to show you what can be done. And then after, we're going to spend a couple of minutes to answer some questions if you have some. Or, like I said, you can send them to me by email, and I can answer them afterwards. Okay, so let's open just a pneumatic sequence that's a bit more complex. So let's go with this one, for example. So we have logic units, and, or, and things like that you can use. You can also put text on your schematic to explain, you can put a lot of things. So here I'm just going to zoom out, zoom all components. So here's my sequence. So when I start simulation, it's going to be a bit quick, but anyway, it's so A plus, C plus, B, so there you go. I'm not going to try to say it, but I could go in slow motion, as you remember, step by step. Or I could have just changed my pressure source. And this is something good also. Remember how we changed the pressure source before to have a bit smaller diameter so there's less air going out? If you put that pressure source in your custom library, students won't even have to do that. They're just going to drag their pneumatic source on the schematic, do their circuits, and right away it's going to be set to have a speed that you want them to see. Okay, so you see again. So C plus, C plus, C plus, C minus, B minus, C plus, and A minus, C minus. We also have some sequencers. So let me open another pneumatic here, additive sequencer. These demonstration files also are available. If you want them, just send me an email and I can send those demos with everything else. So this was a customer who did that using sequencers like that. So if I start simulation, A plus, B plus, so there's another sequence. I'm going to show you a very, I feel like it's a pretty strong circuit, okay? It's a circuit that was made because they had 3 machines and they want to calculate the air consumption of each machine, the power that each machine needs to work with. So I'm just showing that to you because we can do basic circuits in Automation Studio very quickly, very easily. But if you have a more advanced need, you see, for example, here, I'm actually having the watts that each machines are taking versus, its pin. If I create a leak in a machine, then I'm going to take more power to maintain the same rotation speed. If I create a resistive torque on the motor, I'm going to actually create a restriction where it's going, so you can actually adapt and test your system. What happens if that machine stops? Let's say if that motor stops, then everything else will be sent to the others. So, okay, you can do different type of scenarios like that by putting measuring instrument and having different circuit. Okay, so keep that in mind. You can do that, but also we have like the compressibility of the air. As simple as that. I mean, I have 3. I'm going to show you one more cool demonstration after that. This is just 3 cylinders upside down having a weight attached to it. Okay, and I didn't even show you the plotter. I'm sorry. The plotter, it's this icon here. Once you drag it, once you click on it, it's going to open this window. And how this works, you take a component of your choice, you drag it on this window, and it's going to ask you, what do you want to see? Okay, that's why I'm seeing the pressure now, because I already had scheduled that, okay? And then when I simulate, you can see the different reaction depending on the weight, what's going on the pressure side here. Okay, so this is something like that you can show. Let me show you one here that is an air compressor, okay? This is for maybe like just everybody knows how a compressor works, but in Automation Studio, because you can put pictures, you can make it more visual for students to understand. For example, here, if I simulate, okay, I'm building up pressure in that tank. You see my pressure is going up. My motor is spinning, activating the compressor. It's good. And close to 90 psi, this will turn off. Turn off. Then if I take some tools, I'm actually emptying the tank, and at one point I'm going to reactivate the motor to pump back air in the tank again. That's why when you have a real compressor, it stops, it starts, it stops, it starts. That's what it does. But if you take all the tools, at one point, you can barely make it to keep the pressure. You see it's going down instead of going up, even though the motor is always spinning because I'm just taking too much flow. So with the pictures like that, I think it talks a lot more. And if you remove those pictures, all you have is an accumulator and ball valves. That's it. Okay, so this is why the image, I think it's pretty good adding those into Automation Studio. So this is pretty much what I wanted to show you. I mean, if I open one last one, I can go in an electro-pneumatic circuit, and I could open, let's say, a sequence like that, which I did a little A plus, B plus, so it's a little sequence, but exactly like we built before, using 2-cylinder this time. Like this. So if I simulate, I can see my sequence according to the logic I have on the right. So, I mean, if you want, you can take this file, erase all this here, and just do 2 lines like that. And the students open this file like this. Already made with this, they just need to do the logic inside. Or you can simply maybe remove a couple of components to make it not work. I mean, you can create a fault in here and they just have to figure out what's wrong. Okay, so there's different possibilities like that you can do. I mean, I've had people creating circuits and students, they only troubleshoot on the circuit. They only open it, run it, doesn't work. Okay, take measuring instrument, take the pressure, take the flow. What do you think is wrong? Some will have them do the complete circuit. Some half of it. It's really up to you. Okay? Thank you very much again to everyone for being here today. If you have any other questions or comments, please don't hesitate to send us an email. You can visit our website at www.famictech.com/edu to access the educational portion of our website. So thanks again and have a great day.